Hello everyone, I am Anish Srivastav. Today we will discuss about the whole number system. Whole number system is the second number system after the natural number system. In continuation of my videos on number system, this one is the second number system. So today we will discuss about the whole number system. Before discussing, we must know the concept of the zero. The concept of zero came much after the natural number system. Suppose you are having two pens and those two pens were asked by your teacher, then how many pens will be left with you? So that is represented by a zero. So let us include this zero in the family of the natural number system, and that family of natural number system will be known by a different name, that is called whole number system. So whole number system will have 0, 1, 2, 3 and so on. Means the whole number system is the having the numbers 0 and the natural numbers, and this number system is represented by W. In this way I will show this number system, and since 0 is less than 1, so I have put it at the first place. 0 is the smallest whole number, and I will put in this, as you know that this type of representation is called set representation. Set is nothing but a collection of the things. Here we are dealing with the collection of the numbers. Now the another representation of the whole numbers is to represent it on the number line. On number line, how will we represent this whole number system? For that, you see whole number is starting from the 0. So as we know that line has no end, but the whole number is starting from some number 0, so it will have a end, one end. So I will show it by the help of array. Since array has a one end and other no end, so we will start from the 0 and mark at equal distances and put them numbers 1, 2, 3, 4 and so on. Here the interesting thing is that the numbers on the right hand sides of the numbers on the left hand sides are always greater than. For example, 4 is on the right hand side of the 3, so 4 will be greater than the 3. 3 is on the right hand side of the 1, so 3 will be greater than the 1. Similarly, you can say that the numbers on the left hand sides are always less than the numbers on the right hand side. So there are two ways to represent the whole numbers. One is in this form and another is in this form. Let us come to the another point. Discuss the properties of the number system. What are those properties? We will discuss first about the closure property. What is the closure property? As you know that the word indicates close. Closure property. Word indicate close. So how will we define here? Let any two natural whole numbers, any two whole numbers, if I am taking it 2, 5 and add them. If you add them and you are getting here 7. Since 2 is a whole number, 5 is a whole number and 7 is again whole number. So adding two whole numbers, we are getting again a whole number. That means the answer is in the same family. So here we can say the whole number, it is true for every whole number. It is true for every, you can take any whole numbers, any two whole numbers, and if you add them you will get the whole numbers. So that means the whole numbers is closed under addition. So we can check it for the multiplication also. Take any two whole numbers and multiply them, you will get a whole number. How? Suppose I am taking 2 and 5 and answer will be 10. So 2 is a whole number, 5 is a whole number and 10 is again. You can take 0 into 5, answer will be 0. It is whole number, it is whole number, and this one is also whole number. In this way you can say, in general way we can write, let A is any whole number, B is another whole number, we are getting what? Another whole number. Here A, B and C are whole numbers. Okay. For the similarly for the multiplication you can also say A into B, you will get another, suppose D. Here A, B and D are whole numbers. So you can say that whole numbers is closed under multiplication and under addition. Let us check for subtraction. If I take any number 2 and subtract 5 from here, as we know that we will get minus 3. 2 is whole number, 5 is whole number, but minus 3 is not a whole number. So we can say that subtraction is, whole number is not closed under subtraction. Similarly, if you verify for division, it is also not closed. Not closed for subtraction and not closed for division. Okay, let us go to the another property of the whole number, that is commutative property. Before that, let us write what is the whole number. 0, 1, 2, 3. You can take any number from this. Another one is commutative property. Commutative property indicates order. Whenever you think about this word commutative, you think about the order. Let us check for the addition. What is the meaning? If you take any two whole numbers and add them, suppose I have taken 2 and 5, add them, whether they are same. If we reverse the order, first we write 5 then 2. Yes, as you know that 2 plus 5 is 7, 5 plus 2 is again 7. So for any two whole number, if you check this property, it is true. So we can write A plus B equals to B plus A for A, B are whole numbers. So you can say whole numbers system is a commutative under addition. Now we can check it for the multiplication also. I am going to take 0 into 5. Can I write 5 into 0? Yes. In both cases we will get the answer 0. So we can write it. So for any two whole numbers, we can, if we change their order in a multiplication, the answer will not change. So I can write here, if A is any whole number, B is another whole number, and it is the same B into A. For A and B are whole numbers, same thing. Now let us check for the subtraction. As you know that if I take 2 minus 5 and here 5 minus 2, here we will get how much? Minus 3. Here we will get how much? 3. Both are not same. So subtraction is, whole number is not closed under subtraction. So here for subtraction not closed. Similarly, if you verify for the division, suppose I have taken 10 as a whole number, divide by 2. Whether is it same 2 divided by 2? No. So that means it is also not closed under division. Okay. Let's move to the another property of the whole number, that is associative property. When the word comes associative, you think about the association of two numbers. For example, I am going to check for the addition. Why we are checking for addition, subtraction and multiplication and division? Because these are the fundamental arithmetical operations. These are the fundamental arithmetical operations. Let us see. Let us take three whole numbers 2, 3, 5. I am going to plus them, add them, and in a group way. I am going to add them in a group way. First, I will add 3 plus 5 and then plus 2, and another I will add 2 plus 3 and then 5. Let us see whether the answer are same or different. So here 2 plus 8 will give you 10. Here 2 plus 3 will give you 5. 5 plus. So in both way you will get this. If you take any three whole numbers, and in that case it is true for all the whole numbers, means where A, B, C are the whole numbers, we can write in this way or in this way, where A, B, C are whole numbers. Whole numbers means you can first add them these two and then add to them, or you can add first two terms, then third terms, you will get the same answer. It means whole numbers are associative under addition. Similarly, for multiplication, take 2, 3 and 5. I am going to multiply first these two groups and second 2 into 3 into 5. So here you will get 2 into 3, 15, 30. Here you will get 6 into 5. Again you are getting the 30. It means in both ways it is true. So we can say that whole number system is associative under multiplication. Also I am going to take the same number A into B into C, or we can write A into B into C. These properties are useful in a calculation also. That's why we are discussing the properties of the numbers, because by the help of the properties we can reduce the length of our calculations. Now if you check it for the subtraction, it is not true. 2 minus 5 minus 3, if I group them, 2 minus 5 minus 3. What will be the 2 minus 5 minus 3 is 2, it is 0. 2 minus 5 is minus 3, it will be minus 6. So it is not equal. So for again not associative, and for division also not associative. Okay. Now let us move to the another property, that is the distributive property. Distributive property means we have to distribute something over something. Here we will discuss about the distributive property of a multiplication over addition. So distributive property of multiplication over addition will show like this: A into B plus C equals to A into B plus A into C, where A, B, C are whole numbers. You can verify it. It is true for any whole numbers. Let us check 2, 3 and 5. I am going to write in this way. So it is, what is the answer? 2 into 3 plus 5 is 8. It will give you 16. In this way I am first going to 2 multiply 2 and 3 plus then 2 into 5. So 6 plus 10 will again give you the 16. So this property is also very useful, or you can write from this way to this way, or from here to here. It will reduce the calculation part also. Another. Now we will discuss some identities. Additive identities and multiplicative identity. What is the identity? Identity is which maintain your identity. For example, we take any whole number. For addition, I am going to discuss. If you add something, your identity will be remain same. So what will be that number? Here 0. 0 is whole number, so you can say 0 is additive identity. Similarly, we can talk about the multiplicative identity. You have to multiply something so that your value does not change. It means your identity will remains the same. What will be that number? 1. 1 is a whole number. So here 1 is multiplicative identity. Apart from these, we will discuss a little bit about the successor and predecessor. Successor and predecessor. Successor is nothing but addition of 1 to any whole number. For example, A is a whole number. So successor of A is what? Just add 1 to given number. Similarly, A is whole number. Then, so predecessor of A is nothing but 1 less than given number. For example, find successor and predecessor of 100. 100 is a whole number. So successor will what? Just add 1 to 100. So 100 plus 1 will give you 101. 101 will be successor of 100, and predecessor 100 minus 1 will give you 99. So 99 will be the predecessor of the 100. So in this way, I try to take all topics related to the whole numbers. If you have a doubt, you can ask. Thank you.